Good evening, everyone, and welcome to the Real Science Exchange, the podcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. Hi, I'm Scott Sorrell. I'm going to be your host here today, and with me as my co-host in the co-pilot seat is Dr. Clay Zimmerman. Clay, welcome. Good to see you again.
Yep. Thanks, Scott.
We're here with our first of our student showcase, and we're going to be featuring Barbara Dittrich from the University of Wisconsin. Welcome, Barbara. Glad to have you here.
Thank you for the welcome, and I'm excited to be here this morning.
Good deal. You know what I'd like to do first, though? I'm gonna go give your advisor a chance to brag on you a little bit. So Heather White from we know her well. No introductions needed. But why don't you go ahead and tell the audience about yourself just a bit, and then brag on your student for a little while.
You bet. So Heather White, been at UW-Madison now, I don't know, maybe 13 or so years, focusing a lot on transition to lactation period in dairy cows and feed efficiency. Barbara joined the lab just over a year ago, and talk about a student who will jump in and just get started. I think you were around for a week before your study started.
Yeah, actually,
Wow.
when my studies are, we were collecting minus day 7 samples, and that Wednesday, my first cow calf, so I was already sampling that Friday I started, so I just jumped in and rolled with it.
Yeah, good deal. So I understand you're a master's student, first year, you said. So how'd you find your way to University of Wisconsin and Heather White?
So I did my undergrad at UW River Falls. I had a lot of involvement with different research projects. I actually did a piglet project with iron supplementation, a beef on dairy project using Sim Angus and Angus breeding and seeing the difference in that. And then I also did some captive bull work. So I found a love for research. And then I grew up on a dairy farm. The dairy industry I've always had a passion for. And through my undergrad, I developed a love for nutrition. So I wanted to do a dairy nutrition program in a graduate school. So I started looking at different professors, going through just different people, what their research was. And I saw Heather with their transition cow work, and personally growing up with that and seeing like how can I help prevent transition cow diseases. So I reached out and I was like, well, you looking for a student? And here I am.
Excellent. We're glad to have you here. Why don't you start us off? Just tell us about the research that you're doing.
So my current research, I'm co-mentored, also under Dr. Lizzie French, and most of my project work happens at the USDA Dairy Research Forage Center. My project is the effects of alternative forages on milk performance and gas production and multiparous cows, replacing alfalfa silage.
That's a mouthful, isn't it?
Yes.
Typical title for a research paper, by the way.
Yes.
So
But I'll get into some of the nitty-gritty details of what that entails.
Please, go ahead.
So the alternative forages we're actually using are cover crop silages. So we focused on 4 different cover crops: rye silage, triticale silage, and then we did 2 3-way crosses of rye-camelina-hairy vetch and triticale-camalina-hairy vetch. And it was a early lactation study. We had 80 cows on the study, a randomized complete block design. And we started all the cows on a covariant, so we tracked them from minus 7 to 21 days in milk. And during that 0 through 21, they were on our control diet, which just consisted of the alfalfa and corn silage. And then once they hit that 21 days in milk, they transferred to one of the 5 treatment diets. So we were doing a 10% inclusion rate of the cover crop, so all the diets still had alfalfa silage, but we included that cover crop. And then with that, we made sure the diets were balanced isoenergetically and isochronically. So with that, the cover crops tended to have lower protein, so we had to supplement for that. And then the alfalfa silage had lower NDF compared to the cover crops, so we balanced for that as well.
Oh, excellent. Dr. Zimmerman, you selected this research paper. Any thoughts or questions?
I have a lot of questions
I'll bet you do.
about this one. 'Cause I'm from Maryland, and we're known for cover crops there because of Chesapeake Bay. They're huge there.
Yeah.
So I'm curious, first of all, why the 3-way mixes there, and why were some of those picked?
So the reason why we included some of the 3-way crosses is to incorporate some more of the sustainability aspects. I know, like, the hairy vetch is kind of known for nitrogen fixation within the soil, and the camelina, I've heard that's had some pollination purposes. And then a lot of people have been doing multiple crosses that we kind of seen with, I've done a couple webinars and just talking to a couple people within the industry and seen kind of doing a variation of mixes. So we wanted to see if those would have negative or positive effects doing a three-way cross compared to just doing the rye and the triticale.
At what vegetative stage were they harvested?
The boot stage.
Okay.
That was right before, so it's right before the the flower, and so it's kind of the germ stage, and there's the reason why we did rye and triticale. So rye tends to have a more forgiving winter. You can kind of plant it a little more variation, but the harvest window, you kind of have like 24 hours when it's in that perfect boot stage. With the triticale, you have a more leniency in the spring, but then in the fall, when you plant it, the sooner the better. So it's a little more, it's not as hardy as the rye during the winter. So that's why we incorporated both two to kind of have the variation. Like I've heard a lot of people use triticale kind of out west, and rye's been popular in the Midwest. I've heard a couple of farmers using the rye silage. So just kind of having both incorporations and seeing the results and being able to have some scientific background covering that.
How much did the nutrient content of these forages vary then?
The rye and the triticale, when we first did the preliminary nutrient analysis, were pretty similar. However, with the results, we saw a difference with a treatment by week interaction with the MUNs, and our ryes tended to be higher with MUNs. So we're thinking, I'm waiting on the nutrient analysis for them, but we have some preliminary stuff, and the ryes tended to have a higher protein, so we probably didn't need to use as much protein in our diets. And then with the hairy vetch and the camelina, they tended to also have just a smidge more protein, but I think there's more consistency of the trits being similar and the ryes being similar.
So what were the results that you saw in the cows?
So we had no difference in dry matter intake and gas production. However, we did see some differences in milk performance metrics. Nothing significantly different from the control. However, we had a treatment by week interaction for overall milk yield, fat percent, and then the MUNs. And our ryes actually tended to dominate in milk yield. Our control kind of laid in the middle along with our tritway, and then our tritway three-way cross was a little lower. And then our trits did have a little less in the dry matter intake, but it wasn't significant because my p-value was 0.9. So it'll be interesting. I did some metabolite work, microbiome work, and digestibility, which I'm working through the analysis of that now to hopefully answer some of those questions of why we're seeing these differences in our milk performance metrics.
Excellent. Anything else? All right. Barbara, you're a very bright young lady. Heather, you've got a good one here. Got a bright future ahead of you. What's your plans? I know you're just a master's student. What are you going to do after that?
Well, I really have a love for the passion for the research, and I would like to continue on if I find a PhD program that I can continue to work on dairy nutrition. I'm open to all different avenues and different areas. I'm ready to explore. I appreciate being here at ADSA and getting those kind of networking opportunities and learning, kind of seeing what's the future with the dairy nutrition and kind of aspects. I do feel like there is value in the cover crops, so maybe a future potential with that. But if that doesn't all work out, then I probably will go into the consulting industry.
Okay, very well. So you do plan to get your PhD. You thinking about getting that at the Wisconsin, or are you looking elsewhere?
I'm open to elsewhere.
Okay.
So I think it'd be good to broaden my horizons and get some experience elsewhere. Just make some more connections. And I know a lot of people I talk to, just industry personnel and other PhD students. And one of the things they're like, I'm glad I took that opportunity to branch out. And you just get kind of different perspectives. And I think that's important for students to have. Yeah.
So I'd say any prospective professors out there, contact Dr. Heather White. She'll be glad to put you in touch with Barbara. She's a good one. All right. Thank you very much for joining us. So you got a bright future ahead of you.
Yeah, thank you for having me.
Very welcome.
New research is changing everything we thought we knew about choline's impact on the cow and her calf, and top scientists have a lot to say about it. They are presenting new research that supports choline as a required nutrient to optimize milk production, choline as a required nutrient to support a healthy transition, choline as a required nutrient to improve calf health and growth, and choline as a required nutrient to increase colostrum quantity. This new research is solidifying choline's role as a required nutrient for essentially every cow, regardless of health status, milk production level, or body condition score. Learn more about the science that is changing the game and the choline source that is making it happen. Reassure precision-release choline from Balchem. Visit balchem.com/scientistsay to learn more.
Hi, I'm Scott Sorrell. My co-pilot for this session is Dr. Jeff Elliott. Welcome back, Jeff. Good to see you again.
All right, thanks, Scott.
And today we're featuring another student spotlight from The Ohio State University with Irie Mascio. And before we start talking about your research, Irie, I'd like to first to talk to your advisor, Dr. Kirby Krogstad. Would you mind just kind of giving us some background of your student and tell us what makes her so special?
Oh, yeah, definitely. So before I was at The Ohio State, I was at Michigan State University doing a PhD. And like any research project, you need to find really good, reliable undergrads to help make that happen. And Irie was in the dairy program, did dairy judging and dairy challenge, so really was eating, sleeping, and breathing cows. And she got involved with some of our research projects while I was there finishing up my PhD. And I happened to get the position at Ohio State. And the one thing they told me, every faculty that gave me advice said the best thing is good students. Everything else comes second to good students. And so knowing and working with Irie, I was like, well, this is an easy selection. So I started chatting with her as grad school of interest, and I've got a place for you to go if you want it. And so about a year into it so far, and she's run 2 projects and is going to have a 3rd. So for a master's student, she's been ridiculously productive and pretty proud of the progress she's made this year.
Yeah, plans to go on to get your PhD?
Yeah, I'm definitely thinking about going to get my PhD.
Okay, and are you a Michigan native originally?
Yes.
Yeah,
Yep.
Good. Excellent, great school. So go ahead and tell us about your research study.
Yeah, so last fall I conducted a high starch, low forage study. It was a 3x3 Latin square design. We had 3 different treatments. We targeted 20, 25, and 30% starch. It was a 12.6% forage NDF.
Okay, and what was the thesis of this, or the hypothesis, what we were trying to prove?
Yeah, we hypothesized that feeding 12.6% forage NDF will increase milk production, decrease milk fat, and increase milk fatty acids.
Okay, very well. And so what were some of the main results then?
Yeah, so we didn't see any difference in our dry matter intake or milk production. The biggest differences we saw were the low starch diet had the highest milk fat, and that had a linear decline to the high starch diet as well as milk fat yield. We saw a pretty classic milk fatty acid response. The high starch diet really increased in trans 10 cis 12.
Yeah, was that mostly what you expected to see, or were there any surprises?
Yes, we were pretty expecting to see that.
Okay, very well.
So what do you think the response would have been if your forage level had been higher? And that maintained, but you're changed the starch levels?
Sure. I think if our forage level was a little bit higher, we wouldn't see as drastic of a response in the milk fat.
Yeah, I think it's interesting to do these studies that are context dependent like this. And Irie and I have talked about this so often is, if we had a 20 forage NDF and ran starch from 20 to 30%, we might have increased component yields, or you'd almost expect to increase milk component yields. So I think one thing I love talking to dairy nutritionists about, as soon as you shift the context, everything changes.
Right, because there's a lot of times when you raise that starch, milk fat goes down, just like what you saw, but sometimes that protein will elevate up a little bit historically. So just interesting to see that. So how do I take this to a dairyman that I'm talking to in West Texas or California or different places because they all feed differently, what would be your take-home message to them?
Yeah, so really like the take home from the study is, right now we're really trying to chasing components in the dairy industry. And that low starch diet really had the highest milk fat percent and the highest energy corrected milk. So I think from a production standpoint, definitely feeding that low starch diet, I'd recommend to producers.
Do you want to talk a bit about
Sure.
Dairy Challenge?
Sure. So, Kirby, you mentioned that she participated in Dairy Challenge. So I'm highly involved in Dairy Challenge. Balchem is a sponsor, but she actually made a comment before we came up here. I'd just like for you to repeat that and maybe talk about your experience with Dairy Challenge at Michigan State.
Yeah, one of the most rewarding experiences I had at Michigan State was Dairy Challenge. It really got me practical experience working with producers, other students, being very collaborative in the classroom and kind of just putting what we learn into perspective. And I've just really enjoyed that experience.
Okay. And you said you did not come from a dairy farm originally,
Correct.
right?
I did not come from dairy.
Yeah. So you relied on everything you learned there, then were able to take it to where did you participate?
I participated in Visalia, California,
Okay.
spring of 2024.
2 years ago.
Yeah.
Okay.
That's a
Well,
great
glad to hear that.
experience.
Yeah, it is.
So you're just beginning your master's. Do you have any follow-up research to this study that you're planning?
Yes, the next study that actually we're going to be doing this coming fall, similar study, but we're going to be feeding 2 different sources of starch and 2 different starch concentrations.
Very well. Well, Irie, I want to thank you and Kirby for joining us today. This has been a pleasure. Got a bright future ahead of you.
Yes, thank you so much.
Yeah,
very
thanks for
welcome.
having us, Scott.
You bet. Hi, I'm Scott Sorrell. He's Dr. Clay Zimmerman, and we're here to spotlight one of the top students here at the ADSA conference, Dr. Mariano Marino. So welcome. This is not your first time to the pub, at least second.
Exactly, second time.
All right, perfect. Before we dig into your research, what I'd like to do is have Dr. Santos give us a little bit of background about yourself and what made you such a great grad student.
Well, I guess I've known Mariana for about 6 years now. She came as an intern to the University of Florida to work with a colleague first, and then transitioned to work with my group. And I would say she is dedicated. She's got good leadership skills, and she studies. So, yeah, I would say those attributes have made her graduate program to fly through the process without major issues. So.
Yeah. Now, I called you Dr. Mariano, but do you have your doctorate yet? No.
Not yet.
Just
I'll have soon.
okay.
In
Yeah.
3 weeks.
3 weeks. All
Yeah.
right. So
And
I'm
then
a
you
little.
can call me Dr. Mariana.
All right. Sounds good. Sounds good. If you wouldn't mind, just dive into your research. What was the hypothesis and what'd you do?
Sure. So for the research that I presented here on Monday, we looked at the effects of partially replacing oat and corn silage with the stevia extracted of stevia plant on performance in dairy cows. And the idea behind of that is stevia is a herb that is widely cultivated all over the world, but particularly now in U.S. they have been cultivating that more because it's very commonly used in the human diets to replace sugar. But after this extraction of the glycosides, which is the sweet component of the stevia, we have this biomass that if there's no other use, is considered an industrial waste. So the idea is to feed that to cows and see the performance. And that's what we've done with this project.
Kind of curious. I'll let Clay dig into the science, but my question is, I'm going to assume that there's some of the flavor left over. Kind of curious if cows like that. Is that a plus or minus?
Well, it does have leftover taste in it because we're manipulating the diet, and you could feel in your throat it's pretty sweet. The cows, they did like it, but some of the things that I'm going to talk about the diet is because it was very small, very fine particle size. So some of the cows, they changed the behavior a little bit on how they eat there. And when we put a lot in the diet, we start trying to put 50% of the dry matter of the diet as a stevia. Some of the cows did not eat. So we had to change a little bit before starting the
Yeah,
diet.
so it was fine because of the processing to
Yeah,
extract the
exactly,
flavor. Yeah,
after
got it.
extraction.
Makes sense.
Yeah.
They did produce sweet milk.
So
That's not true, is it?
so how much forage replacement did you do?
So we had 3 different diets. All the diets we had 40% of grain mixture and 60% of forage. One of the diets we didn't include stevia at all. One of the second diet we had 25% of the diet dry matter as stevia extracted, and the third diet we had 40% of the diet dry matter as stevia.
So on the 40% diet, how much forage was in the diet then at that point?
60% total forage, and then we had 12% of corn silage, 8% of oat silage, and then 40% of stevia. Yeah.
How does that fine material behave in the rumen? Do we know?
Well, we had hypothesis that because I'll tell you about the results, but they ate more. So the idea is we believe that the increased the passage rate of those animals because it was very fine, and unfortunately they reduced digestibility, and that's why we're gonna talk about. But they reduced milk production too, even though they ate more. So we believe that because it's very small, it goes through the rumen very fast, and stevia has another component which is it has a high content of lignin, so it's not very digestible. So the rumen microbes probably are not digesting much of that fiber that stayed there, probably not for very long, but they also was not very digestible.
So with the lack of so there's no effective fiber basically,
Exactly.
right? So what happened with milk fat production?
Milk fat did not change because, well, those two things, the cows lose a little bit of weight too. So we believe that those cows that were fed stevia probably had more preformed fatty acids going to the milk. But milk production in general reduced, but milk fat, we did not see any differences. Yeah.
Yeah. So the cows ate more. We attribute that to rumen retention time that is just shorter. Huh? But you have to remember that although it doesn't have much physically effective fiber, the fermentation of the fiber is reduced. So the generation of organic acids would probably be less. So on a per unit of dry matter consumed would be a lot less. And probably, although those cows ate more, they ate 29 kilos versus 25 kilos. Yeah? And they produced in the control diet, if you will, about almost 50 kilos of energy cracked milk, and in the high stevia was about 47 and a half or something like that. Probably they produce less total organic acid, even though they consume more dry matter. So
There's no much of a risk of milk fat depressing.
probably less, although the physically effective fiber was greatly reduced in that diet.
Yeah.
What stage of lactation were they?
They were 133 days in milk when we started the trial. Yeah.
So I'm going to guess that this biomass feeding it to dairy cattle is probably not a good use for it unless there's some other ways to maybe, I don't know, maybe not grind it as fine, or I don't know. Thoughts?
Yeah. Yeah. Well, they have to grind as fine because they want to extract as much as they can of the glycosides. But for lactating dairy cows, it's not ideal because it's very small and greatly reduced the particle size or the physically effectiveness of the diet. So yeah, maybe for heifers, but we didn't try that. We tested lactating dairy cows, and yeah, it's not ideal.
Yeah. Any follow-up research you're planning with this compound?
Well, so far not with us. Do we have any?
There might be some,
Yeah.
but so the whole idea behind is because they just planted about I think 2,000 acres of that in just around the corner of us, and the company behind that wants to be self-sufficient, to have all stevia sweetener produced in the U.S., nothing brought from other countries. So they want to integrate the production of the human edible compound with that, and then generate energy to run their plants. So that was the purpose of, can we use that and then have the residual manure and uh, uh, for methane production to run their plant. So obviously, it's not something that you would replace forage, just because just the lignin content, you wouldn't classify that as a high quality forage, but it still can be utilized. Our cows produce 47 kilos of milk, so it's not like you're not going to be able to produce milk, but it's not your first choice for forage. It's a very peculiar case, but at the same time, it exemplifies the importance of physically effective fiber and fiber quality. Yeah, so you can use that as a good example of reduction in particle size and increasing lignin can really compromise digestibility. Yeah.
Yeah. Mariana, you said you're going to be graduating in about 3 weeks. What are your plans after graduation?
Well, I am very happy to share that I'll be joining Balchem as a dairy technical service in California and South America. So,
Absolutely. Glad to have you.
I am very excited about that.
me too. Starting soon.
Well, congratulations and welcome to the Balchem team.
Thank you.
Yeah. Hi, I'm Scott Sorrell, and I'm surrounded by badgers. I've got to my right here is Dr. Ryan Prawley, an ex-badger and current Balchem employee, a newly minted tech service up in the Midwest for Balchem. Welcome aboard, Ryan.
Always great to be here.
Yep, absolutely. We got Dr. Heather White over here. She's a rock star in the nutrition world. Heather, glad to have you back again. I see you brought a student with you today. Can you tell me a little bit about her?
You bet. But before I do, I got to clarify one thing here, Scott. There's no such thing as an ex-badger.
Oh, okay, once a badger,
he's-
always a badger.
That's right. So alumni 3 times over, Ryan, probably down there. So I did bring a student with me, another alumni. So Sophia Green here finished her undergraduate program back in January at UW-Madison, and she will be starting as a veterinarian student in the fall and has been working in my research lab since her first week of class as a first-year student and will continue to do so this summer and as she starts vet school.
Awesome. Anything you want to specialize while in vet school, or?
I'm hoping to do primarily dairy, but I'm focusing right now on food animal production medicine more generally.
Okay, excellent. So we're here featuring some research that you presented here at the ADSA this week. Was that an oral presentation, poster?
It was a poster presentation
yep.
that I did on Tuesday morning.
Yeah. Well, so tell me a little bit about that.
Yeah, so my project focused on evaluating feed sorting behavior and chemical composition of TMR and roughage intake control feeding systems. And for anyone who's listening who's not familiar with roughage intake control or RIC bins, these are an incredible research tool that we use to measure individual cow intake, which helps us answer a lot of our bigger research questions. And while it's a really valuable tool, one part of these feeding systems that has gone unexplored is feed sorting. And feed sorting can impact the composition of the consumed diet versus the formulated diet. So when we're doing an intensive nutritional study using these RIC bins, it's really important that we're making sure that our results are accurate and have a lot of integrity. So we evaluated the feed sorting in these bins by particle size and then the resultant nutrient composition. And how we did this was in 2 replicates. Each replicate we sampled across 3 24-hour feed days, and we sampled in 3-hour staggered intervals. So we got this really nice 24-hour picture of the feed day at each hour time point. And to look at the feed sorting, we separated the feed into 5 different sieves, which broke it down by particle size. And what we saw was that feed sorting is primarily occurring in the last 12 hours of the feed day. But during these last 12 hours of the feed day, the cows aren't eating as much feed as they are in the beginning of the day, which is consistent with a diurnal feeding pattern, right? More intensive feeding in the first 12 hours of the feed day. Most of the consumed as fed feed is with this balanced diet by particle size. But while particle size is an important characteristic of the consumed diet, we really wanted to investigate the nutrient composition and see if the particle size deviation was substantial enough to cause an impact in the nutrient composition. So we took those samples and we dried them and we ground them and we ran analysis on that. And what we found was that compared to the fresh feeding at hour 0, we didn't see a change in the chemical composition of the nutrients, which is positive. We really wanted to see that. So between the intake and the feed sorting by particle size and the consistent nutrient composition, we feel very strongly that the RIC bins are a very accurate and useful tool for dietary intake research going forward.
Okay, very well. So it was more about establishing that these are the good research tools as opposed to maybe totally understanding how to reduce sorting and that kind of thing? That was okay.
Yeah, sorting is a behavior that we know and understand to be true for dairy cattle. And the unique thing about these rick bins is that it's an enclosed space, right? So we wanted to make sure that compared to a traditional concrete bunk, we weren't seeing exacerbated feed sorting because it's an enclosed space. They have their own entry to the bin, and they might be able to more effectively sort given the space and enclosure of the bin.
Now, Sophia, I overheard you say 5 sieves. That's more sieves than I remember counting when I did a Penn State shaker box.
Yeah, so we didn't use the Penn State shaker box. We used the Wisconsin oscillating particle separator. This is an approved method of separating feed by particle sizes with ASABE, and it's very unique to Wisconsin. What I really enjoyed about separating feed using this machine was that it's automated. So we're eliminating a lot of the question and error and the labor and logistics of having to shake down over 2,000 feed samples that we had at the end of this study. And so it was also really helpful when reporting and writing up this project because I was able to definitively say the oscillating circumference, frequency, and duration that we use. So it's a great tool to use to automate a lot of these processes.
Were there any surprises or learnings about the animal behavior, sorting behavior itself?
We did expect to see feed sorting, which is what we saw. Less surprising on the sense of what we saw with the cows, but more so what I saw as a team and a growing lab member. As an undergraduate, this was a huge leap of faith for myself and Dr. White. So I think the biggest learning curve was not necessarily with the research itself, but with the research team.
Yeah. Scott, if I can add something to that, I think this is a really good example of, a student stepping up and taking an opportunity. So I've heard you tell students countless times, put yourself out there, take an opportunity, take a chance. I certainly tell them that as well. This idea was one that was born out of, I am not kidding you on this, a van drive from one of our research stations north of Madison back down to Madison. And we happened to have our multi-institutional feed efficiency team meeting. And so we were taking it virtually from the van. And one of the other universities asked a question about, well, do you think you get more sorting in the feed bins because they're enclosed? Do you think that the diet that the less aggressive cow is eating later in the day is the same? And, anecdotally, we're like, oh, no, it's fine because we see it. It looks good. We've never had a difference in particle separation or anything like that. But it raised the question. Right? Okay, so if they're wondering that, other people are probably too. And we knew there were multiple universities looking at putting in these units. So we said, why don't we just answer it? And then we'll know for sure. And then the, of course, obvious question that comes next. And Ryan spent many years in my lab, so he knows the one that comes next. It's who's going to do it? Who's going to lead it? And Sophia, as an undergraduate student, you were a sophomore at the time, I think. Second year student said, I'll do it.
Huh.
And we're all kind of looking around and we said, sure, let's do it, right? So she tackled and she mentioned 2,000 samples very casually, but thousands of samples. They had to be dried and then ground and then composited and sent off for analysis and then the shaking on top of that. And so just a team effort, learning communication, learning organization, learning how to process samples and be the point person, not just the person that's helping and assisting. So I think it's just a great example of taking an opportunity and running with it. And we're actually not only presented the abstract here, but getting ready to submit the publication, which Sophie is the first author on. So
yeah, that's excellent, huh? What a great experience. Heather, thank you for sharing that story. And also thank you for bringing Sophia here. Sophia, do you have any idea where you're going to be practicing once you graduate?
Oh, I don't know yet. I'm super excited to get into vet school and see what opportunities arise in both dairy and other species too. So I'm keeping a lot of my doors open and my eyes on, just becoming a great veterinarian and a great veterinary student.
Well, no doubt in my mind you're going to be a great one. So thank you for joining us today, and good luck to you.
Yeah, thank you.
All right.
Thanks, Scott. Thanks for having me.
Yeah.
Thank you, Heather.
Hi, I'm Scott Straw. I'm here with another student spotlight. This time we're going to be spotlighting Peyton McDonald from Michigan State University. We're here also with her advisor, Dr. Barry Bradford. Barry, kind of give us some background about your student and maybe what makes her special.
Peyton's a super talented individual. She, her undergrad was in biochemistry, a lot of animal focus, but she didn't go through a traditional animal science curriculum and comes with a degree of enthusiasm for science that is unmatched by almost anyone I've ever worked with. So
I
it's a lot
kind of
fun.
got that when I was talking to her over here. I'm like, I am in so much trouble on this one.
To be fair, we had to institute a little ban on new research ideas about partway through her degree program because her enthusiasm level is pretty high.
Yeah, I'm going to guess her work ethic's just as high.
Yes, it is.
Absolutely. Well, Peyton, welcome to the Real Science Exchange. We're glad to have you here. Why don't you just start off by tell us a little bit about your research?
Sure, yeah. So predominantly my program focuses on how we can improve calf health, whether that's through colostrum or pre-weaning diets, or even just looking at the dry period. Today I'll be talking about some of the work we're doing on the calf side, where we're looking at physiological changes in response to pre-weaning diets. And so we're really looking at a common calf foot disease that costs us millions of dollars every year and kills a lot of calves, which is known as scours or diarrhea. So we're trying to ask some questions about how, when we feed animals different things, how are their intestinal tissues responding to common pathogens that we would isolate from these disease animals.
Okay. Can you talk a little bit about the protocol then? What were you feeding them, the different ingredients?
Yeah, I think so, right?
Yeah.
Can we?
So we're kind of asking, does the traditional milk replacer vary, or the response change if our calves are fed the traditional milk replacer or transition milk for a few days followed by milk replacer? Or we also have a bacillus probiotic that we're looking at as well for the full pre-weaning period.
Okay. And what were some of your findings?
That's a good question. So this is more of a method-based experiment that we're running. And so we're looking at how within the first week of life, animals that have different diets are responding to, or we collect their jejunal and ileal tissues and then stimulate them in the lab with common scour pathogens. And we're seeing that while there might not be a pathogen difference in response to either a viral or bacterial stimulation, we think we have tissue responses, and they vary by different segments along the small intestine.
You say you think, so it's...
Well, I'm pretty sure the stats tell us, but we have a small sample size right now.
Got it.
So I don't want to be too optimistic.
Yeah.
Big picture, yeah, she's doing a hugely ambitious study, right, looking at long-term outcomes. And so, yeah, maybe give a sense of how long it's going to take before we know kind of the full story.
Yeah, so we started enrolling calves last September, and we're anticipating that we'll enroll the final animals this September. And so right now, because we have a serial slaughter time point assessment, we only have 6 animals actually completed for this assay. And so we'll probably wrap those up hopefully in the next 2 or 3 months.
Okay. And then any follow-up studies then that have in mind?
Not immediately. My new idea ban is still in place for the rest of the year.
But I think it's interesting to talk about the heifer arm of the study, right? That from a production standpoint, that's a super interesting piece of it.
Yes. So we're using similar diets with heifers, but we have a larger sample size, 40 per treatment, where we're trying to address those performance characteristics, assessing if maybe we can improve their pre-weaning performance with growth and health. Are we going to see these outcomes post-weaning as well as into their first lactation?
Okay, interesting. Very well. Your PhD third year, what's your plans after you graduate?
Yeah, I'd like to go into academia. Hopefully, I would like to be at a land-grant institution where I can do basic research as well as some applied work. I have a growing passion for calf extension right now, but I'm really open to anything as long as I get to do science and have fun
Okay.
doing it.
Keeping your options open then. Well,
Mhm.
whatever you decide, you're going to excel. You're a very talented young lady, and
thanks.
I've enjoyed getting to know you today. So
Oh,
thanks for
thank
joining
you.
us.
Thanks for having me.
Barry, thanks for joining us.
Thanks a lot. That
Yeah,
was
you
fun.
bet. Hi, I'm Scott Sorrell. This is Dr. Jeff Elliott with Balchem Corporation. We're here with Dr. Kevin Harvatine and his PhD student, Elena Staffen. Kevin, if you don't mind, just start us off by telling us a little bit about Elena. What makes her a great PhD student?
Yeah, so just a little bit quick background on Elena. So she came from Cornell in her undergrad. So of course Cornell is good program and Dairy Fellows program, and came in with that really broad background and understanding the industry. And we threw some challenges at her. So she'll tell you a little bit about AV difference, but it's one of those projects that you kind of look at the technique and you say, hey, this doesn't seem so complicated. Why don't more people do this? And then you start into it and you figure out, oh, geez, there's some problems and complications here. So she might tell you a little bit about a few of the landmines that we stepped on as we went, but she did a really great job kind of learning from the challenges we had in adapting and going to the next iteration, and came up with a nice data set at the end.
All right, very well. So why don't you just jump right into it and tell us about your research.
Sure. So I looked at the effect of increasing doses of palmitic and stearic acid on mammary metabolism and milk fat production. And so I wanted a wide range of doses just to understand the effect of a wide range of concentrations. So we fed second lactation Holstein cows in mid-lactation 0, 150 grams, 300 grams, 500 grams, or 750 grams of palmitic or stearic or no supplement control.
Free fatty acid?
So the stearic treatment was free fatty acid. Both had about 10% oleic. The palmitic treatment was a combination of free fatty acid and calcium salt. It was a product that was already out.
Very familiar with that. Megalac?
No, it was Spectrum Fusion.
Oh, okay.
Yeah.
So I started my marketing career as a business manager for Megalac back in 1988.
Oh, neat.
Yeah, it was kind of neat. I am that old. I am that old. So what were some of the findings?
Yep. So we were trying to understand why in the field you see an increase in milk fat more commonly with palmitic acid than stearic acid. So we found that palmitic acid increased milk fat yield more at lower doses compared to stearic acid. So we saw a response at 300 grams for palmitic, but not till 750 grams for stearic acid. So then we wanted to look on the mammary metabolism side to just understand why that might be the case. Why are we seeing these differences in my own trial, but also in the field? And so we did a technique called AV difference, and that's essentially just sampling from a representative artery running to the mammary gland and then from a vein running from the mammary gland to try and understand uptake of a nutrient. And so what we saw is that the mammary gland increases its AV difference and uptake of palmitic acid when you provide more, but not of stearic acid. So that's why we're seeing these differences in milk fat responses.
Okay. Dr. Harvatine mentioned some landmines along the way. What might those be?
Yeah, there's definitely a few landmines. There could be a lot of data and just a lot of error and variability when you are sampling for AV difference. Just in the sampling itself, it was initially a challenge to try and sample from the mammary vein. We wanted to sample often, so we initially tried catheters, but those would kink or the cow would lay on them. It didn't really work. So we went to needle sticks next, but the cows weren't a huge fan of them initially. So we kind of found
They think they're getting bit by a fly.
Yeah, like it wasn't a huge reaction, but it was enough for them to just pinpoint kick the tube right out of it. So we eventually went to using EMLA, like lidocaine cream, and sampling closer to the mammary gland, and we found that that was a perfect medium. So that was one
So
of
was
the
it
challenges.
difficult to find help and support to take those lab samples since they knew the cows might be kicking?
No, our lab mates were pretty on board with helping out, so I appreciated all of their support in that. They weren't afraid to help out. So
Yeah, good. So the question I always like to ask, so how do we take this information and apply it to the field? What do we do with it if we're on a dairy?
Right. So we're trying to essentially just understand why palmitic acid might be, increasing milk fat yield more than stearic acid. So this just shows us when we provide more of both in the diet, the mammary gland is taking up more of that palmitic acid than of the stearic acid. And so it just shows us that the stearic acid is probably going to other tissues or for other utilization besides for just milk fat yield.
And the palmitic's not then.
You get about, when you feed extra palmitic acid, we got anywhere from a 25 to 35% transfer efficiency. So for the amount that's absorbed, some of it will still be utilized for other areas, but more of it's essentially going to the mammary gland than for stearic acid.
The one thing to point out there's kind of unique in this is we were titrating across these concentrations, and I always think back to some of my PhD advisors, Dale Bauman, he was really big on dose titrations in time courses. And those are really important for us to understand biology and physiology that's going on, right?
Yeah. And maybe if we could go back to discussion point prior to getting on here, you'd mentioned that you also did some work on melting points and how that, on the hardness of the fat and stuff. Can you expand on that a little bit, what that means?
I did. So right around the time that we were designing the study to look at AV difference, the Buttergate situation came out. So essentially, it started in Canada, but people were worried that feeding palmitic acid was causing an increased butter hardness and reducing butter spreadability. And this was a perfect situation, or not necessarily perfect, but a good situation to test that. And so we already had like an increasing doses of palmitic acid and then another common fat that's fed, which is stearic acid. And so we were able to look at solid fat content of our milk fat essentially from these trials and found that palmitic acid supplementation actually increased solid fat content, which would increase butter hardness, while stearic acid supplementation actually did the opposite because the mammary gland converts a little over half of stearic acid to oleic acid. And so oleic acid is an unsaturated fat. It'll be liquid, or increased liquid at room temperature, whereas palmitic acid, most of it stays as a saturated fat. It doesn't, not much gets converted to unsaturated fat in the mammary gland.
So is that, make sure I heard you right, is that thinking about your trial we were originally talking about, you're getting increased milk fat at lower doses. However, you're getting the harder fat. So how does that play in the industry? It almost sound what we want both.
Right. So I guess it just depends on what you're using that milk fat for. If you're somebody that's just producing butter and you want a more spreadable butter, while palmitic acid might give you more milk fat, it might also increase the hardness and decrease the spreadability of your butter. But if you're using that milk fat for other applications like ice cream, which is really cold, or if it's cheese on your pizza that's really hot, those extreme temperatures aren't going to have as much of an effect. This is more at room temperature where we see the differences.
Yeah, we really like to make that point because some people are worried that we're pointing out something bad about butter, and it's not that it's bad, it's just different. And I think it provides the opportunity that if somebody wanted to pay somebody more to make butter that was more spreadable, we know how to do that, right?
From a fatty acid perspective, what are the differences in the butter compared to the ones fed palmitic versus the non?
Right. So when we feed palmitic acid, we do increase palmitic acid content of milk fat pretty considerably. When we feed stearic acid, we increase milk 18 carbon, but it's increasing stearic some and then increasing oleic to a greater extent.
Okay. Interesting. Very interesting. Anything else, Jeff?
I'm good. No, that's good.
Kevin, we ask all the hard questions, have we?
I think you covered it very well.
Yeah, so I want to thank you for bringing Elena here. Before we go, Elena, you're getting ready to graduate here in a bit. What are you going to do after graduation?
I am, yeah. I'm still applying for jobs and trying to find the next step, but looking to do something with extension or technical consulting just to get some more experience in industry.
So in industry. Okay, very well. You heard it, folks. We've got a good one here, and she's looking for a job. So thank you for joining us today, Elena.
Thank
Good
you.
job.
Thank you.
Thanks, Kevin. Good evening, everyone. My name is Scott Sorrell. I'm going to be your host here for this session. Today, we're at the 2025 ADSA meetings, and we're highlighting some grad student papers and presentations. With us today is Dr. Melissa Cantor from Penn State University, and her student Jillian Plower, and she was at Penn State, no longer there. She's since graduated and is gainfully employed. Melissa, why don't you give us some background on your star student here?
Absolutely. So Jillian Plogger is an amazing student, and I was very sad to not keep her for a PhD. So she grew up in West Virginia, and she did her undergraduate degree in Mississippi State and became kind of interested in cows at first. And then she went to the dark side, which is calf nutrition world. When she came to my lab after working at a big 6,000 cow dairy, she was the calf manager there. And I found her on Facebook.
Oh, wow.
So, yeah, she's been great. She's an awesome student.
Yeah, good. So welcome, Jillian. Now, you did a poster, and you're going to do a presentation all around fiber use in dairy calves, both. And you're going to take a look at the gut health aspect of that. Why don't you start off by just kind of giving us some background? What was the hypothesis and some of the thinking behind these trials?
So I know that in calves, it's really been historically kind of frowned upon to offer forage to pre-weaned calves. And so I thought it would be really interesting to see, can we actually improve performance in growth, average daily gain, body weight? And then I also love diarrhea, so I wanted to add that on too. And so we wanted to investigate different diarrhea characteristics in those pre-weaned calves and see if that fiber could really help out, because there's also evidence that dietary fiber does help diarrhea in humans and piglets and different species.
Okay. So tell me, why do we traditionally think that hay is contraindicated in those calves?
So a lot of the research that has been used against hay has found that the gut fill is increased in calves fed hay, and that could potentially decrease calf starter grain intake, which we know is super important for rumen development in those young calves. And so that's a lot of the thinking behind it. And we know that the hay is not going to directly promote the papillae development. So that's where a lot of that research that came out and said, hey, feeding the hay doesn't help promote the rumen development. So we want to avoid that.
All right. Can you talk a little bit about the protocol for the study? Just set it up for us.
Yeah, so I had 64 calves that were in 32 pairs. So my experimental unit was the pair, since they were pair housed. And I paired those calves at around 5 days of age. This was after I got birth weights and I took serum total protein levels on all of them. And so I paired them up, and that is when I started offering the pelleted hay to my treatment calves. And so I followed those calves in my performance trial for 70 days, and that included a 1 week of the post-weaning period. And so I did all sorts of measurements on them. I did body weights, I did beta-hydroxybutyrate. For the health outcomes, I did fecal scoring every single day on those calves until they were 30 days old, and took fecal pH, blood glucose. So there was a lot involved in these trials.
Okay. And then tell us about the results.
So the results for the growth performance outcomes, we did find a tendency for a hay by period interaction. And so I divided my study into different periods. So I had periods 1, 2, 3, and 4, with period 1 being the diarrhea risk period, period 2 being the full milk period, period 3 was the step down weaning period, and then period 4 was the post weaning period. So I found that during periods 2, 3, and 4, we had the tendency for that interaction for hay calves to have higher body weights. And so that was an interesting outcome. We didn't find an effect of hay on average daily gain or solid feed efficiency. So that is a bit of an interesting finding as well in conjunction with that tendency. And then for the diarrhea outcomes, we did see that there was a decreased severity of diarrhea in those calves. And so that was very interesting by offering that pelleted forage.
And what about length of the incidence? Did we see a reduction in that?
So we did not actually find any association of hay with the length. And my average length of diarrhea for both pairs, both treatment pairs and control pairs, was around between 3 to 4 days. So pretty standard length.
Yeah. Just want to drill down. I'm going to turn it over to my colleague here, but the tendency for higher body weight. So how much difference was there?
So I believe there was about 8 kilograms difference at some points. And so they were pretty significantly heavier during those periods.
I'm surprised that wasn't significant.
Yeah, I know. It was so close.
Yeah.
Well, it's always when you do research at the pair, right? At the pen level, you
Yeah.
lose a lot of that ability.
Okay, just didn't have enough in.
Yeah, just didn't have enough in. And actually, she was pretty tired at the end of that trial. But in hindsight, when I saw that, I was like, oh, we should have followed another cohort, another group.
Are you looking to maybe follow up with that, Melissa, with maybe another grad student?
That's an interesting point. I think if I were to repeat this study, I would include heights because it was very obvious that there were some other body measurements that we didn't capture, such as height, wither height. They were very different visually. And still in the barn, the heifers that were on the hay treatment, I can tell who they are just by looking.
So those were taller?
Yeah, they were way taller. And I don't have
hay.
the data to say that. That's all anecdotal, unfortunately. But they had commented how Jillian's trial had created this size difference between the heifers. And now a lot of these heifers are already being bred. Some of them are getting really close to calving in. So I am kind of curious to see if anything had carryover effects.
Yeah.
But you
so
know
assuming,
how that goes.
let's assume that's a real effect.
Yeah.
What do you propose might be the reasoning behind
Like
that?
what mechanism is going on? That's an excellent question. Yeah, I'm not exactly sure, Jillian. I don't know if you have any speculations, but it goes kind of the only thing I can think of is maybe more calcium or something, right? Coming from that forage source, but I actually don't know, and I don't have the heights to even say, oh yeah, this happened. But my guess, if I had to give it some sort of gander, would be that these animals are not just eating, basically surrounding milk feeding, right? We know that when calves drink milk, a lot of times then they'll transition over to that grain, eat a little grain. These guys had this trough of hay to play with in a pretty boring pen, right? There was nothing else in there besides the hay. And then obviously we did have a starter bottle as well because our cook required that. So part of me wonders if maybe it's just a bunch of small meals and they were constantly giving themselves feed, I mean, feed efficiency was not different. But it's a big guess. I don't know the answer. Yeah.
Okay. Yeah. So you mentioned early on about the philosophies of maybe holding off on forages till an animal's weaned or the calf is weaned. So now, after this study, would that bother you to feed a pelleted?
You should talk about the cross-sucking that we looked at too.
Yeah, so I would say I see no issue with offering pelleted forage pre-weaning. There was no decrease in the calf grain dry matter intake between those pairs, which we know is one of the most important outcomes. And we did see a little bit of that increase in body weight, which we also missed out on rumen morphology and weights with that. But I would be very interested to see if they had heavier rumens, since some previous literature has found that. And so I think, especially with some of the regulations in the EU, we tend to follow in their footsteps. And if a farmer needed to offer forage and they didn't necessarily have the means to grow it, they wanted to make it easier, I think pelleted forage could be a good option for that. However, like Dr. Canner said, we did do additional analyses on cross-sucking, and we did not find any association of the pelleted forage with cross-sucking behavior in the calves. And I watched thousands and thousands of hours of video.
3,500 hours.
And we found no difference.
Yeah.
So I wouldn't recommend it for that.
Yeah, some of the other studies have found that in bigger groups of calves that we can actually decrease the abnormal cross-sucking behavior that we see in group house calves by offering a forage source. So that's where the rationale came for that.
So maybe going more to you, Jillian. Did your work at Penn State. Now you're in California, and we probably need to highlight that a little bit, but differences in calf raising in those two areas, or how common is paired housing? Just
Yeah, so I've only actually been in California for about 2 weeks now,
Mhm.
so I'm pretty
Okay.
fresh on the
Brand
ground.
new.
Yeah, so several of the farms that I have been on are doing group housing, and so I think that's great to start out. We know the benefits of pair housing,
And they're
and
doing that early on.
yes,
few
yeah.
days.
So once they're born, they're putting them together. I've seen it on auto feeders, and I've also seen it. I was on a small farm that just put them together. They had about 5 calves at a time, and they just all lived together in a single pen. So that has been interesting to see.
Good deal. Fascinating research. Any other big things you'd like to share with us relative to that?
We've got a couple papers coming out, so that's something to look forward to. We've got one in Frontiers of Vet Science that's been accepted, so that should be published here pretty soon, and we've got a couple others submitted, so be on the lookout for that.
All right, good. So now I understand you're graduated, got your master's degree, and now you're in California, 2 weeks. Tell us what you're doing out there.
So I'm working for Dairy Farmers of America as a calf specialist. So I am in charge of the Western region. And so I do calf consulting, I sell milk replacer, I just basically help farmers if they have problems with their calves, questions, I walk calves, do all of that business for Dairy Farmers of America, for our farmer owners.
Yeah, good deal. Melissa, you brought us a winner today. I appreciate that. You guys have been
course.
great guests. Wish you the best of luck, Jillian.
Tonight's Pubcast toast is brought to you by NitroSure Precision Release Nitrogen. Maximize rumen microflora with the consistent release of NitroSure to turn up the dial on rumen efficiency and productivity. Visit Balchem.com to learn more.
Hi, I'm Scott Sorrell. He's Clay Zimmerman, and we're here with the final installment of our student showcase with a very special guest, Jair Perales-Giron. Welcome back. This is your 4th time being spotlighted here. Before I jump into your research, what I'd like to do is to give your advisor an opportunity to brag on you just a little bit. So, Adam, if you wouldn't mind, would you introduce your student here and tell us what makes him special?
Well, yeah, thank you, Scott. I mean, Jair's been with me for 4 years, and I think you still say his name better than I do. So, I think the fact that you've had him here 4 years in a row says pretty much what I feel about him as well. I mean, he's done huge amount of work in our lab, moved the area forward in fatty acids, been able to work with and collaborate with the Contreras lab a lot, and tie a lot of things together. He's a great person.
Mm-hmm.
You know, gonna miss him when he leaves.
Yeah.
I will miss you guys
Yeah.
as well, for sure.
I'm gonna get emotional here in a minute. So, but no, he's you know, especially the study we're gonna talk about today. That's all him. I said, you design the study you want, and I'll get the funding. And he's been doing a lot of interaction studies, if you guys seen. So this is all him, and it's his best study as well.
Yeah. Well, great segue. Jair, why don't you just go ahead and then tell us about the research? What was the hypothesis and protocol?
Because we've been working with fatty acid supplementation, my dissertation is focused on checking like interactions between other dietary nutrients or feed ingredients with fatty acid supplementation. The only one that I was missing for having like the whole picture was checking different metabolizable protein levels and dietary inclusion of fatty acids. So in this study, we checked like 2 levels of MP, low and high MP, and 3 levels of fatty acid supplementation, 0, 1, and 2%. And we were looking for trying to catch any interactions and try to see what there could happen when we were feeding both or using both strategies.
All right. What were some of the key results that you found?
I mean, we have a lot of good results, but I think that the most important thing is like when you are using a high MP diet plus the highest fatty acid inclusion, those cows were producing 9 kilograms
of energy corrected milk extra compared to the cows that were in the lower end diet, low NP and zero fatty acid inclusion level.
And was that expected? I mean, that's a big difference.
We were expecting some good results, but we were a little bit shocked when we saw that result, because I mean, yes, we can see and we have seen that both interventions could have like a good result when using independently. But even when we didn't observe the interaction, that additive effect was like amazing.
How long were the treatments applied?
So we start feeding the treatments right after calving, and we fed those until 22 days in milk. After that, we stopped feeding the treatments, and the most important part as well is that we were still seeing results in the carryover period, and those cows were producing around 4 kilograms more of energy corrected milk, the cows in the higher end diet compared to the cows in the lower end diet. So it's a strategy that works, but even when you stop using or feeding those, you can see the results, the residual effects.
What was the amino acid composition of the MP?
We use like blood meal to increase like the metabolizable protein, and we use like rumen protected methionine and lysine to increase the NP level of those diets. So the low NP mix had heat treated soybeans and the distiller DDGS, and we replace those by the blood meal and the rumen protected amino acids, and we balance a little bit more using soybean meal.
And what was the fatty acid profile of what you were
supplementing? The fatty acid profile, yes, I was missing that one. So it's like our probably star fatty acid mix that we have like a 60% palmitic and 30% oleic acid.
And that was fed as the calcium salt at 1 or 2%.
A calcium salt, 0, 1, and 2%. So at the end, we had like 6 different treatments.
So the unique thing here that Javier did was, there's been a couple studies like Bill Weiss, Tom Overton, and the Cornell group have both looked at, higher MP diets during that transition and seeing good results. We've obviously seen some good results of different fatty acid blends, but, tying them together now, and the effects are additive.
Yeah.
Right.
Yeah. I think using both strategies it's amazing the results that we got using both.
Yeah. So what were the main effects that you saw?
The main effects, fatty acid supplementation, like increasing like the regular stuff like milk fat yield, of course increasing milk fat content, but MP increase milk yield and increase milk protein yield as well. So, but when you are putting those together, of course, the energy corrected milk results are gonna be following like a similar pattern.
Yeah, but I think one of the big things from that was increasing MP had as big effect on milk fat than it did on milk protein. It increased both, and actually in that window, the higher MP increased milk fat more than the fat supplement.
Yep. Yeah, and that's something that actually Dr. Van Amber was talking about that like 2 days ago in the symposium, showing how some amino acids could impact that, lysine, and also because if we have like a blood meal, we can have like the branch amino acids that are coming from the blood as well, having some direct effect of an mTOR pathway. mTOR pathway could lead to higher like fat synthesis, but also lysine and methionine acting like in gene expression, increasing some also transcription factors that are related to milk fat synthesis. So I mean the effects that we saw with MP, those were really good as well.
So one of the ways I've been trying to think about this lately is, additional amino acids, additional fatty acids to the diet are somewhat expensive. Get good return to them, but what else can we do to the diet to get a better return to them? So you could argue, if I'm putting in additional amino acids, maybe I put in some additional specific supplemental fatty acids, and you're getting the return from both, and overall driving even more milk components, which, you know, the marginal, then we should be getting a better, maybe getting a better return to both of them.
Yes, yes, for sure. I mean, also something that we saw in our studies, like we observed like a two-way interaction in dry matter intake, and it was really interesting seeing that in the high MP diet, fatty acid supplementation increased dry matter intake as well. So, but on the other one, in the low MP diet, was the opposite. We observed like a quadratic effect in both, in the low MP going down, but in the high MP going up. So trying to tie that with the thing that Dr. Locke said is like, okay, in the high MP, the cows and fat supplemented diets, those cows were milking more and they had to eat more to reach like their requirements. So it's really important that we need to keep challenging those cows. I mean, if we are gonna feed them the right amount, and if we are gonna reach their requirements, for sure they are gonna start milking more, because the recommendation is like 2,700 grams of metabolizable protein. The low MP cows were eating around 2,300, so they were kind of limited, but the ones in the high MP, they were eating like 26, around 26, 2,700. So yes, if we are delivering the right nutrients to the mammary gland, for sure we are going to see the results, even if you could argue, okay, prices and such. I mean, we did like a small economic analysis for the last tri-state, checking how much the intervention could cost, but we got like a income over feed cost of $212 per cow across the whole study. So if you put those numbers in a 1,000 cows herd, you will see that it's going to be paid.
Yeah. Hey, as we get ready to kind of close out here, what are some of the biggest unanswered questions, and what kind of future research do you have planned?
I mean, there are still a lot of, I mean, we need to keep researching during the transition period, and there are some interventions that we haven't done in the dry period. I mean, that's something that we need to keep exploring. I know that right now high oleic soybeans are like a hot topic. I think that there is going to be potential to feed those. Actually, we are doing some studies with high oleic soybeans, checking the effect of those in the pre and postpartum and peak period. I think there's still potential to check some other things there. I mean, choline, checking other kind of interactions with fatty acid supplementation. I mean, we demonstrate that we don't need to be afraid of feeding fat during the transition period. We still need to see what other tweaks in our diets we can make, not only to get the interaction, but also, again, additive effects are still valid for the producer.
I think another one would be good to follow up with this is when we put these on the carryover diet, it was a pretty dull diet. We didn't do much with it. We wanted, but what would have happened if we'd kept that higher MP, a higher fat level in those, fatty acids levels in those? Would they have taken off again, like we've seen before with our 60-30 blend in a peak cow? That's another follow up, I think.
Yeah. I think that cows are there for being challenged, and we as a nutritionist, we need to keep challenging them, because we haven't reached the plateau yet. So there's still potential to keep improving the meal responses.
Dr. Locke said he's going to miss you. What are your future plans?
I am looking like to get to the industry. I like research, but also I like doing nutrition at a farm level. So because I like talking to people and visiting people and interacting with them. Also because that could be a good experience for me to make me a better nutritionist, knowing different experiences at different places. So those are the kind of things that I would like to do after graduation.
Okay, and when is graduation?
Everybody
always looks at the advisor.
No, I mean, he's been really good.
Yeah.
He's been really good about that. It's been, it's in video, so you can show me that video later. No, I mean, we are planning to have everything done by November. So also I am really excited because we are going to have new facilities at MSU. So I try to push my finish time just to see the new facilities and try to see how
I
can
suggested
we.
he could be the first study run there, but he said, yeah.
I will help with the transition, but I won't be completely in charge of the study.
Yeah. Well, Haier, we're going to miss you as well. This is your 4th time here.
Yeah.
I don't know if we're going to get a 5th, but if so, we'd be glad to have you back.
I hope so. And thank you so much. Thank you so much for inviting me. I mean, it's been a great experience, and it's nice seeing that the research that we are doing at Lock Lab, it's been seen by the people who cares, producers, researchers, and colleagues, and you guys.
Yeah.
Thank you so much.
No, you're very, very welcome, and you got a bright future ahead of you. So, yeah, absolutely. Adam, you've this is like your 3rd time this week. You could almost be the host.
I've done a few of them now. I think I've probably got the patter down reasonably well.
Do you want to try to close this out?
I'll try. Yeah.
Okay.
Yeah. So to our loyal listeners, thank you for joining us today. We hope you've learned something. I hope you had some fun. I've certainly had some fun, and we hope to see you next time here at the Real Science Exchange with Scott, probably not with me. And here at the Real Science Exchange, it's always happy hour, and you're always among friends.
We'd love to hear your comments or ideas for topics and guests, so please reach out via email at anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars takes place on the first Tuesday of every month, with the top research and nutrition topics that will impact your business. We also include small ruminant, monogastric, and companion animal-focused topics throughout the year. Visit balchem.com/realscience to see the upcoming topics and to register for future webinars. You can also access past webinars and search for the topics most important to you.